AP Chemistry students. Today we're going to be doing the lab determining the molar volume of a gas. And first thing we're going to do is figure out the mass of the magnesium ribbon that we're using. Now, to just weigh this on the balance, even the analytical balances, this is too small, too light to get an accurate mass. So instead what we're going to be doing is multiplying its length by the conversion factor, which the conversion factor for the magnesium is 0.009194 grams per centimeter. So again, the conversion factor is 0.009194 grams per centimeter. And then if we measure the length of this, so let's put this up here. So measuring the length of this, it's kind of hard to see. That is, try and get it in focus here. I'd say 3.10 centimeters. So by multiplying that together, you can get the mass of this piece of magnesium. So then next, we're going to take a piece of copper wire and we're making a little cage to try and hold the magnesium in so that it doesn't float away during the reaction. We'll see how that works. And I'm going to put the magnesium in. Inside here. Yeah, kind of challenging. We'll see. Hopefully this is good enough to keep the magnesium in place during the reaction. Okay, so I've got that. And so now we're going to put the copper, this end of the copper, into a rubber stopper. Maybe. There we go. So there we got it. All right, so we've got that in the rubber stopper. Okay, and I think hopefully this is long enough. It's about, yeah, let's make it a little longer. I think this will work. Well, let me get it. Trying to make, crap. Did it again. Trying to make this long enough. My magnesium is really brittle. Well, we'll figure that out. So that it will fit up in here. It's not really, I guess that will work. Okay. All right, so the next thing that we're going to do is measure out 15 milliliters of hydrochloric acid. I want to fix this cage just a little more. There we go. So okay, so there's my hydrochloric acid, and this contraption here, this is a eudiometer tube. It looks kind of like a burette, but it's not. It doesn't have a stopcock or anything. It has a closed end on one end and then an open end on the other with the measurements. So the trickiest part is first we're going to pour, I think can see this. Okay, I'm going to pour the hydrochloric acid into the eudiometer tube. Okay, so we have, you can see we've got 15 milliliters of the hydrochloric acid, and then the hardest part is I'm going to fill the rest of this tube up to the 50 milliliter mark with water, and I've got to keep it tilted. I'll get some water. We've got to keep it tilted so that it does not mix, so that the water and the acid don't mix until we want them to. So that's really the hardest part. Okay, so now I've got some distilled water. Let me set this up here for a second. Okay, now, so I've got my hydrochloric acid here, and again I've got to add my water. Very slowly and carefully. Up to there. Okay, so now you really can't tell right now where the water versus the hydrochloric acid are separated. Hopefully I did that. Okay. And then, hang on one second. Since we're going to adjust the size of our magnesium, a little piece of the magnesium just broke off, which is very tiny. A quarter. Where did I lost it now? I don't even know where it went. Oh, there it went. It is a quarter. Well, it would help if I'm using the right side. It is, let's see. Sorry, it's 0.6 centimeters. So subtract off 0.6 centimeters from your total length of the piece of magnesium. So now what I'm going to do, now I got my water in here, I'm going to insert, and if I did this correctly, nothing will happen just yet. So right now, where am I? There we go. I'm inserting the magnesium in the and into the eudiometer tube, and again you can see nothing's happening right now because this is just water, and magnesium does not react with water. And so now what I'm going to do is get this ready to go in here. So I'm going to keep my finger over the hole of the stopper and then invert this and get it into the beaker of water, the 400 milliliter beaker of water. And then you can see air bubbles going up. And then pretty soon the hydrochloric acid is going to mix. You can kind of see, I don't know if you can see it too easily on film, but you can kind of see some mixing going on right here. Of the hydrochloric acid is starting to fall down because it's more dense, and as it falls down, it is now starting to react with the magnesium. So you can start to see some bubbling going on with the magnesium, so I'll kind of sit that there. And as more hydrochloric acid descends, you're going to get more and more of a reaction. So you can see right here, now we've got quite a few bubbles. So we'll let that sit and react. And make sure you're recording all of your data. And we're going to wait till hopefully we can get all the magnesium to be reacted. And those bubbles are the gas, so you need to think about the chemical reaction between magnesium and hydrochloric acid. What that gas is that's forming, that's what all those bubbles are. Let me try and stand that a little better so you can really get, now it's really reacting. Hopefully our magnesium will stay in its cage while the reaction's occurring. So we still have a lot of bubbling going on. It's kind of hard to see the magnesium, but it's still in there getting jostled around as it's reacting. So we're still reacting. Still quite a bit of magnesium left, but the fact that there's still bubbles going on means it's still reacting. And let me kind of pan out here. So now you can see our water level is down to the 35 milliliter mark. Sit. Well, let me see. I guess I can pan out a little bit. Now, while we're waiting on that to finish, let me look up. You will need to know the atmospheric pressure. I believe that's something in your that you need to fill in your data table. So right now the pressure is 30.55. That's in inches of mercury, so you will need to convert that. So 30.55 inches of mercury, that's our atmospheric pressure currently. Now the reaction is pretty much, looks like it's done. Our magnesium, we've got just, our magnesium got so small that it escaped the cage now. And so we just have a few more bubbles as the last little pieces of magnesium are reacting. Let's see if you can see that. Sorry, I know I keep, I wish they put the camera in the center of the iPad. It's very deceiving. So we'll let those last couple pieces finish reacting. We're right about the 41 milliliter mark, but don't record that yet because we're gonna have to use this big old, I know in your directions it says 500 milliliter, but I actually have 1,000 milliliter one to kind of equalize it. Looks like we're almost all gone. Got one teeny tiny little piece of magnesium still bopping around there. I think it's way too small for you to see on here. Plus it's very blurry. Oh, you might be able to see it kind of. I wish this thing would focus. So there's a little thing in the back of the udiometer too that's kind of bouncing around the number 4 and 41. Now it's kind of over the number 1. That's a little teeny tiny piece of magnesium still holding on. The fact that it's bouncing around, it's hard to tell, but there are bubbles coming off of it, so it's still reacting. Now again, all of those bubbles were the gas that's produced, that's almost gone, when magnesium reacts with hydrochloric acid. So that's what has replaced the water that is in this tube, and it looks like, I think it's gone. I don't see it anymore, don't see any bubbles. Okay, so let me get this repositioned. And the next thing really isn't that big of a deal. So what I'm going to do is I'm going to take the udiometer tube out of the water. I got to keep my finger over the hole of the rubber stopper and kind of shake it up inside the graduated cylinder. That kind of equalizes the udiometer's pressure inside with the air pressure, which is why I gave you the air pressure. And then once we do that, we'll record the final water level inside the udiometer tube. It's really not going to change much. And then we'll also have to take the temperature of the water bath that we used for down here. We'll take the temperature of that. Well, I might as well do that right now. Let's do that right now. Whew, it's cold in here. It's only 19.6 degrees Celsius in here. So let's see what the water temperature is. I'm sure it's warmer than that. Maybe not. Yeah, I guess the water temperature is 19.7 degrees Celsius. Tad bit chilly. Can you see that? Yeah, you can see that. Okay, so that's our water temperature. Let's see. Let me make sure I get you all of your data that you need. Okay, yeah, I gave you the barometric pressure. We're not going to do a second trial. We're just going to do this trial. I think it's going to be pretty good. Okay, so hopefully I can get this. Okay, so now what I need to do I got to keep this submerged. I've got my finger over it, and then I'm going to put it, oh boy, let me add a little bit more water to this. Well, this is hard with one hand. Hopefully you can see that. Can you see that? Okay, and I have little fingers, so, okay, I think I got it, okay. Now I'm gonna juggle this, kind of bounce it up and down, make sure you can see it. Get out any remaining, oh, it did change a little bit. So we're equalizing, trying to equalize the pressure. Okay, so I would say that we are, can you see that okay? Okay, I know that's far away. So looking at the graduated cylinder, the uniometer tube, we are at 40.7. 40.70 would be the volume of the water that we have remaining. Yeah, I let that go. Okay, so that, don't look at that. The 40.7, that was our final volume of our water. Okay, so now you have all the data, so you can plug that in and ultimately figure out the molar volume of the gas that we formed. And let me know if you have any questions. Have a good day.